Okay, so I think I left off with the first video of showing you this system of equations that we established. So we have the objective function and the three constraints as all variables on the left and all constants on the right. And we had established this table that has the four rows, one for each of the equations, and then the coefficients of the variables. And these three s's are slack variables, and they only get a 1 in whichever equation they appear, right? So that's where we left off. So what we want to do here is use this tableau to maximize this objective function. And I'll leave it to others to give the theory behind how the simplex method works and why it works and all of that. I'm interested in the application of the simplex method. This can be used for thousands of constraints if if you have them. So it's very transferable to real problems if you can get them into a set of linear equations. So our goal here is to manipulate these equations so that the coefficients of the x and y, the coefficients of the x and y in the objective are 0. No, not 0, not 0. Non-negative, I should say. We don't want these to be negative. Okay, so our first step is to manipulate these equations, these all of these equations, so that we have a 1 with all zeros in each of these main variable columns. So I have that in this first column. I want it in these other two as well. So the first step then is to identify what is called a key column. That is, what's the worst possible value of x and y that would work against maximizing? And of course, it's the most negative, right? So that's the key column. And to find the key row, I have to do a test over here of the constraint variables. Hold on. Here's an example for this first one. I'm going to divide the value of the equation by this worst case. And that's 1,000, 1,500 divided by 1, and 2,100 divided by 3. So I'm going to pick the lowest value again. I'm maximizing, right? So I want my ideal is the highest value. So the lowest value is the worst case. It's the key one. So I have this cell right here is the key value for this first tableau. So I'm going to convert all of the values in the key column to a key value of 1, and all of the others are 0. By, first of all, I'm going to multiply this key row by the reciprocal of the key value. And then I'm going to add multiples of the key row to all of the other rows so that the key column goes to 0. And you'll see what I'm talking about. You're getting all these words mixed up possibly. So here it is again with the key column and the key row. I'm going to change this key row so that this equals 1. So I'll multiply that by the reciprocal. Can I do this? Oh, for God's sake, come on here. I'm going to do the reciprocal here. So 1/3 times this row gives these values in that third row. And I want to add a multiple of this equation to each of the other rows such that these column values go to 0. So the key column is the second one. So that's this. And the key row is the third one. So that's this row. And this equation that I kind of hurried through, maybe I should go back now. Let me go back just for a minute. This gives the values in any of these other rows. So I already did the third one. I'm going to do these first three using this equation. So for example, the multiplier is the value in the key column for any given row divided by the key value. So this m for this one would be minus 200 over 3. For this one, it would be 3 over 3. And for this one, it would be 1 over 3. Those are the m values, the multiplier values. Now, for the values in row I, say the first row, I would take the value, say the first one, and subtract this element of this key equation times the multiplier. And we're going to work this out, okay? We're going to work this out with an example. So let's go through it here. So the multiple of the key row to row 1. So the multiplier is this, and then this just represents the third row. That's the key row. That's the third row, and then each column changes, right? So let's say, for example, we're interested in the first row, second column. So I want to see what does this equal when I transform it. So row 1, column 2, I have row 1, column 2, that's the numerator of the multiplier, so that's this one, divided by the key cell, which is this one. So that's 200 minus 200 divided by 3 times 3. Third row, second column, right? So it's this one. So if I do that out, it comes out to 0. Now let's do another one. Let's do j equals 3. The column equals 3. Never mind that k. To take that out. So so we're still working on the first row, and we're going to look at the third column now. I want to transform this number. So it is the first row, and the key column is 2, divided by the key value, that's the multiplier, times the cell. Well, I've got the row, the key row is 3, and then the column is the third column. Column J is the third column. So this is minus 180 divided by 3, right? That's that one, times 2. 2 is this cell right here, right? It's the key row, third column. It's basically, I'm just multiplying this whole row, each element in this row, by the multiplier, and then adding it to this first row. That's all I'm doing. So I did it with the minus 200 and got a 0. I'm doing it with this one, minus 180, minus that little equation here, and that'll come out to minus 4667. So I'm going to replace this value with minus 4667, And if I keep doing that, and I'll do that for all of these, right? All of these values. If I keep doing that, I'll end up with the second tableau. Right, so I did it for the first row. I'll do it for the second row, the third row. I already did the fourth row. And so this is Tableau 2. I can redo that same thing. I can apply that same equation now to Tableau 3. So the key column will be this one because this is the most negative, and then I'd have to find out what the test value is over here and find the key row. I don't remember which one it is, but whatever. Oh, it's actually it's this one. And then you know, just do the same thing. So I end up, the third tableau gives me ones and zeros in these three columns, and that's what I'm looking for. So I have this. This is the solution. So I know from this tableau, P is 1. So its value, the maximum value of that objective function is 596,000. The value for the y term is 300. And the value for the x term is 500. That's the solution to that linear programming problem that I presented. Okay, that's it.